Okay, on these notes, we're going to be talking about types of chemical reactions. So you're going to need to know how to identify them, all the different types, and how to predict the products if you're just given the reactants. Okay, the first type of reaction is a synthesis reaction. This is simply when two substances combine to form one product. So you can see the basic reaction, A plus B, representing two reactants, form to make a single product. Okay, here are some examples of a synthesis reaction. For example, magnesium and O2 combine to form one product. So basically, to be able to identify this type of reaction, just look for whether or not it has just one product. So there's no plus sign with another product, it's just one product. Okay, a decomposition reaction is when you've got one reactant that breaks apart into two or more products. So you see in this basic reaction, you've got AB, and it breaks down into A plus B, and you could have more than two, but basically you're looking for that single reactant that breaks apart. Okay, so here are some examples, and you see on the left of the arrow, you've got several reactants, and it's just one reactant, but then you've got multiple products because it decomposes or breaks apart. Okay, the next type is a single replacement reaction, and this is where one element replaces another element. So basically, one element kicks the other element out and replaces it. So if you think about it like a dance, it's like somebody cutting in and dancing with your partner. So a reactive metal will replace another metal that is less reactive. So basically, a metal has to be more reactive than another metal in order to be able to replace it. And then nonmetals will replace other nonmetals. Okay, so this is the activity series. You don't have to write this down because we'll give you a copy of this in class, but you can see how the metals at the top, these are the, so lithium up here is the most reactive, and as you go farther down, we're decreasing in activity. So in this one, the least reactive is gold, which means that gold cannot replace any of the elements that are above it. It's just not reactive enough. But lithium is really reactive, and it can replace almost every metal on that list. So if one metal will replace another metal if it is higher on the activity series, and this is because it is more reactive. And also notice this halogens. So those are those nonmetal gases over there by the noble gases, and it's the same thing. Fluorine can replace chlorine, bromine, and iodine. So basically it can break apart the bonds and replace them. Okay, so here you can see the basic reaction. So you start out with A, so this is the metal, and this is B and C. So we'll think of B as another metal. So A is going to come in here if it's more reactive, and it's going to kick B out. So it stole C, so it's together with C now, and now B is all by itself. So one element replaced one other element, so it's a single replacement. Okay, so here you see some examples. You see aluminum over here. It kicked out iron, so now iron is by itself, and aluminum took its place. Same thing here. Chlorine kicked out potassium, and now bromine is off by itself. So you just look for these single elements that are kind of by itself, and that tells you it's a single replacement. Okay, a double replacement is basically where two metals swap places. So they change partners. So A and B are together, C and D are together, and then they basically switch partners. So they swap places. So C and B are now together, and A and D are now together. Now, in order for this to happen, we don't use that activity series anymore. That was only for single replacement. For double replacement, we'll use the solubility rules. So in order for these to happen, you have to form one of three things. A precipitate, which is a solid, a gas, or water. So, and we use the solubility rules to determine whether or not a reaction will actually take place. Okay, so here's some examples of a double replacement reaction. So you see here magnesium and hydrogen switched places. So now the hydrogen is with the oxygen, the magnesium is with the chlorine. So if you think about people at a dance, they swap partners and dance with the other person's partner. Okay, so here are the solubility rules. Oh, sorry, these aren't the rules yet. So this is solubility rules are a list of rules used to determine whether or not a double replacement reaction will take place. And again, in order for a reaction to take place, you must produce a gas, a precipitate, which is a solid, or water. So the solubility rules tell us whether or not a precipitate will be produced. Okay? So if a solid is produced, you're going to see a small S written next to it, S for solid. Then L for liquid, G for gas, and AQ, meaning it's soluble in water. And soluble means it can dissolve in water. So, a solid cannot dissolve in water. So keep that in mind when you're looking at these rules. Okay, so these are different solubility rules. You do not have to write this down. We will give you a copy of these in class. So if something is soluble, it will dissolve in water. And so all these will create an AQ, which means an aqueous solution. So all salts containing the ammonium group or the group 1A ions like lithium, sodium, potassium, rubidium, cesium. All salts containing nitrate, acetate, or perchlorate. All salts containing group 7A ions like chlorine, bromine, and iodine. And all salts containing sulfates, with the exception of barium sulfate, calcium sulfate, lead-2 sulfate, and strontium sulfate. All these are soluble in water and will create an aqueous solution. Okay? So these will not create the liquid water or the solid that we need in order to make a double replacement reaction happen. Okay, these are all insoluble, meaning that these are the ones that will create the solids. So these will be the ones that will help this double replacement reaction actually happen. So all salts containing silver ions, lead-2 ions, and mercury-1 ions. All salts containing carbonates, chromates, hydroxides, oxides, phosphates, and sulfides. And salts are just ionic compounds, which is a metal plus a nonmetal. And with the exceptions, group 2A chromates, except for barium chromate, are soluble, and group 2A hydroxide, except magnesium hydroxide, are soluble. Okay, a combustion reaction. So a combustion reaction, the basic reaction is you've got some kind of C and H, a hydrocarbon, O2, and you always create CO2 and water every time. The only thing that changes is how many carbons and hydrogens that you have. And in these reactions, heat is released, so these are typically explosive kind of reactions. Okay, so C3H8 plus O2, CO2, and water, that's a combustion reaction. And again, these two numbers can change, but for the most part, you always have CO2, water, and O2. The rest of it's always the same. Okay, last thing, a catalyst is a substance that increases the rate of a chemical reaction by lowering the activation energy, but it itself is not consumed. An example of this is an enzyme. You probably remember this from biology. And this allows chemical reactions to occur at a rate that sustains life at normal living temperatures. So without enzymes, a lot of your body processes couldn't happen fast enough for you to be able to survive. So catalysts are very important, and they're found in chemistry as well. So here is a kind of a graph. So it shows how without a catalyst, you would have to go all the way up here in order to get enough energy for a reaction to happen. But a catalyst lowers the amount of energy needed, so the reaction happens much faster.